Good morning, children. Good morning.
Hi, sir.
Today I am going to take the lesson what I have taken in the last day. From that continuously. Before that, first of all all of you take your rough notes, pen, pencil and everything and get ready for the class. So first I am going to ask some questions what I have taught in the last day. So last day, first what are the fundamentals, basic things in this electrostatics I have taken. First I have defined what definition first I told to learn well. Define electrostatics. So all of you know I think. So that definition you have to know what is electrostatics. Next, second one, another question I have told. Basic properties of electric charges. So that basic properties, there are three basic properties are there. Electric charge, then conservation of charges, next quantization of charges. These three basic properties are there. So this also you know well what is the electric charge, then what is the definition of law of conservation of charges. That is important, that you have to learn. That is a 2-mark question. What is law of conservation of electric charges? The total charge in the universe is constant. The charges neither be created nor destroyed. In any physical process, the net change in charge is always 0. So that you know. So like that basic properties, 3 properties also together we have to write for 5-mark question. In the same way, we have learned the fundamentals, the historical background of charges we have learned. So that also you have to know. So what is the charge of this amber and rubber, same polar charge, negatively charged, then glass rod positively charged, that also you know. Like that. Next I have taught a small problem. Next I taught about this Coulomb's law. Coulomb's law, all of you know the Coulomb's law. So Coulomb's law, similar, some characters are similar to universal law of gravitation, which one we have learned already in the 11th standard. So what are the similarities, what are the characters, what are the differences, everything we have learned. So it is important, so you have to know that again and again, you repeat it and you learn it. Okay, so today I am going to teach about another principle in this electrostatics. Okay, that principle is called as superposition principle. That is called as superposition principle. You see here, what is the special property of this superposition principle? That only we are going to learn here. Last day we have learned, the first class, Coulomb's law. What this Coulomb's law saying? The interaction between 2-point charges, Q1 and Q2. 2-point charges. That interaction or the electrostatic force between or relation between these 2-point charges we can learn, or that force, electrostatic force we can find out by the use of Coulomb's law. But in the same case you see, this is a charge Q. It is a system of charge. That is a system. That the system of charges means many charges are there. So in this system of charges, different Q1, Q2, Q3, Q4, like this many charges are there. So like this, if there is many charges are there, that all the charges are exerting some force on this charge Q. So how can you find out that? All the charges, Q1 have some interaction here, then Q2 have some interaction here, Then Q3 have some interaction, Q4 have some interaction. So this distance we can say as R1. So this R. So all distances are also different. Okay. So this one, how can we find out this superposition? Through this Coulomb's law. So Coulomb's law can explain the interaction between two point charges only. So if there is a system of point charges, we can learn, we can find out the electrostatic force exerted this Q is experiencing by all the other charges. For finding this, we are using this superposition principle. We are using this superposition principle. What this superposition principle saying? According to this superposition principle, the total charge acting on a given charge is equal to the vector sum of the forces exerted by all the other charges. So the total force acting on a given charge is equal to the vector sum. The vector sum of all the other charges. Okay, this only what? Superposition principle. So once more I am repeating that definition. You see that definition is important. This is a 3-mark question. Superposition principle. Sometimes they can ask for 2-mark question also. Okay, so what is superposition principle? This defines as what? The total force acting on a given charge is. So the total force acting on this force is a vector quantity. So the total force acting on a given charge is equal to the total force acting on a given charge is equal to the, we know the formula for this electrostatic force. What is the formula for electrostatic force? K into, wait, I will define later. First we can see this, recall that yesterday's formula, Coulomb's law. So Q1, Q2 divided by R 2 1 square R2 1 cap. Okay, so this is the formula. This is the K is the proportionality constant, Q1 and Q2 of the charges, and R21. This is the distance between the two charges. This R21 is the unit vector. Okay, so what is this superposition principle defining? According to superposition principle, the total force acting on a given charge is equal to the vector sum of all the other forces exerted on it by all the other forces. So once more I am saying you see, the total force acting on a given charge is equal to the vector sum of the forces exerted on it by all the other forces. So how can we write this in the formula? Here, one more thing you see, that Q1, this Q1 is exerting, first this one we can write as Q1 according to our formula, Q1, Q2, Q3, Q4, this one Q5, this first charge we can take as Q1. So Q2 is exerting a force upon Q1. Then Q3 is exerting a force upon Q1. Q4 is exerting a force upon Q1. So Q5 is also exerting a force upon Q1. So the Q1 is experiencing a force because of Q2. Then Q1 is experiencing a force because of Q3. Q1 is experiencing a force because of Q4. Then like that Q5 is experiencing a force because of Q1 is experiencing a force because of Q5. Like this, all the charges are exerting a force. So if that Q2 is exerting a force on Q1, that is not affected by the next force, the force by Q3. So this is different. Q2 separate, Q3 exerting another force, Q4 another force. So all the vectors we have to find out. So because of Q2, what is the force it is applying upon Q1? That is F12. F vector 1, 2. That means what? The force exerted upon 1 due to 2. So, next, Q because of 3. F vector 1, 3 equal to K Q1 Q3 divided by Q3 1 square. No, R3 1 square, then R3 1 cap. So this is because of the point charge Q3. This point charge Q3 is exerting another force upon this Q1. Like this, all the charges in that system, not only 5, lot of lakhs and many, we cannot say numbers, such number of charges are acting upon this particular charge Q1. So, how can we denote this according to the formula? So, all the total charges, like that taking time, F vector. So, F vector 1, this the charge force of this total is equal to F vector 2 vector 1 2 plus F vector 1 3 plus F vector 1 4 plus etc. F vector 1 n. So this is the total force. So this total force, how can we show this? So we have to substitute our formula. We know the formula for that. So F1 total, how much amount of force that charge Q1 is experiencing by other charges. The vector sum we have to find. So here 1 by, what is F1 to? 1 by 4 pi epsilon 0 Q1 Q2 divided by R 1 2 square or 1 2 cap. This R cap is denoting unit vectors because magnitude. What is the meaning of unit vector? Unit vector means that magnitude also unit, then direction also unit. So we are saying this as unit vector. In the same time, we have to add the next force 1 by 4 pi epsilon 0 Q1 Q3 divided by or 1 3 square or 1 3 cap. This is the force because of the point charge Q3. So next, because of point charge Q4. So 1 by 4 pi epsilon 0 Q1 Q4 divided by Q14 square or 14 square or 14 cap. So then plus etc. plus what do you write? 1 by 4 pi epsilon 0 Q1 Qn divided by R 1n R cap 1n. So this is the expansion we have added. So here F1 vector total, what we can do is this 1 by 4 pi epsilon 0 we can take it out. Can you remember the value of this 1 by 4 pi epsilon 0? 9 into 10 power 9. Nm square c power minus 2. Yesterday we have learned. So don't forget that value. So now we are not utilizing that here, but we want to take this 1 by 4 pi epsilon 0 commonly outside. Now all the remaining Q1 Q2 by R 1 2 square or 1 2 cap, then plus Q1, Q3 by R13 square R13 cap like this. Everything plus Q1, Qn divided by R1n cap. Like that, we have to take it out. This 1 by 4 pi epsilon 0. So, this 1 by 4 pi epsilon 0 is K. So, that one we can write as K value, K. Understood all of you? This is superposition principle. These two laws, the Coulomb's law and the superposition principle are very, very important. The superposition principle and Coulomb's law are very, very important in electrostatics. They are very important, but they cannot derive from one another. Okay, so it is important one. So we have to know this well. Next, I am going to teach this electric field. What is electric field? What is electric field? You see here up to now we have learned yesterday's, the previous day's question and today's question. Both the classes we are learning about the interaction between two charges. If one charge is here, if we are keeping another charge at nearby or some distance, the two are interacting one another. So this interaction determined by Coulomb's law. How that two charges are interacting. Now I kept a charge, I considered a charge kept here. That one I have taken as Q. That charge we can take as, say, as source charge. Another charge I have brought here and placed near to at a distance, that is Q0. That is test charge. These two charges, I kept these two charges, they are interacting each other. The interaction, sometimes it may be repulsive, sometimes it may be attractive. So, whatever it may be. So, that this repulsive or attractive that interaction, how it is coming? Because they are keeping at a distance. So, this one we can say as action at a distance. If we are keeping a charge near to another charge, they are interacting each other. So this is called action at a distance. When the two charges are kept at a distance, they are interacting each other. So this only called as action at a distance. Okay. So then I kept one charge here, one charge nearby. But how this second charge know? Another one charge is here. How this second charge know about the first charge? So for this, the scientist Michael Faraday given an important one term that is called as electric field. That is field. He given for this purpose only he introduced this important term, that is field. Okay. So according to Faraday, every charge exerting some lines of force. So in the universe, several many charges are there. All the charges creating some electric field around us, around it. So this electric, because of the electric field only, first this charge, this point charge I kept at one place. This charge have some field. So it is creating. So at a particular distance, it is exerting that electric field lines. So when I kept the second charge nearby, so it is in the field of the first charge. So they are interacting one another. So the first charge getting some force or electric field because of this second charge. Okay. So the first charge we can take as source charge. The second charge we can take as test charge. So what is Coulomb's law? For this two charge, how can we write the Coulomb's law? F vector, the force experienced by this charge Q due to charge Q0. F vector is equal to K Q Q0. K is the proportionality constant. Q is the charge of the first charge. Q0 is the charge of second charge divided by the product of the both the product. Then R square. The distance between that two charges. The distance between the first charge and the second charge, or the source charge and the test charge, R. That is R square. Then that line of action, R cap. So the line of action is R cap. In this line only that force is acting. So that unit vector we have to write R cap. Okay, so this is the Coulomb's law for this source charge and the test charge. Next, we have learned in this Coulomb law the important aspects. Same manner here for this electric field also we have to learn the important aspects. So before learning the important aspects, you see here, we know force is a vector. F is equal to K into Q0 divided by R square into R cap. So we have to find out the electric field. So what is electric field? Electric field E is equal to force is a vector. Force divided by Q0. So what is electric field? Here two charges Q0. So because of this experiencing a force. So here force experienced by this Q0. So this force Q experiencing a force due to Q0. So that's why F divided by Q0. So we have to write F. K Q0 divided by Q0 R cap into R square. This R square also. Q0 cancel. So what do you get? K proportionality constant Q divided by R square R cap. Okay. This is the formula for electric field. This electric field is also a vector quantity. For denoting the vector quantity, we have to write this symbol vector. This is unit vector. Okay. Now, this electric field have SI unit. The SI unit of this electric field is Newton Coulomb power minus 1. Newton Coulomb power minus 1. So we can write in symbol NC power minus 1. NC power minus 1. This is the formula SI unit of this electric field. Next, we can learn about the important aspects of this electric field. Now listen here. same charges only we have taken here for our important aspects. You see, this is the test charge, this is the source charge, Q, test charge is Q0. Both are at a distance of action of distance. Now, this Q0 exerting a force upon Q. So, listen here, in the first charge Q, if the charge, we know there are different types of charges. There are, how many types of charges are there? Two types. Positive charge, negative charge. Okay. So, sometimes this Q may be positive or negative. So, in this case, first we are going to take this, consider this Q as positive. So, if Q is positive, what will you do? The electric field points away. The electric field points away from the source charge. If the source charge is positive, the electric field points away from the point charge, source charge. Okay. So, if it is positive, if this source charge is negative, the electric field points towards. The electric field points towards the source charge. That is the first aspect. Okay. Once more I am saying that, you see, if the point charge, source point charge means that is source charge. The source charge Q is positive. The electric field points away from the source charge. If the point charge Q is, source charge Q is negative, the electric field points inwards towards this source charge. Okay. So, this is the first aspect. So, second one, we can take the second one as, you see, we can find out the force. So, how much the force experienced by this source charge due to Q0, the test charge. So, that Q0 E vector. This is the second aspect. This is the force experienced by this Q. So, the next that we can say this. This is the Coulomb's law in terms of electric field. This F is equal to Q0 E vector is the Coulomb's law in terms of electric field. Okay, second aspect is called as Coulomb's law in terms of electric field. Then in the third, okay, so third point we can see, we know, for this we want to know the formula. F vector, this formula I have to write here. That one important always we are using. K Q divided by R square into R vector. Okay. So, in the third aspect we know this Q is the source charge. So, the force experienced here, this source charge is independent of the test charge but depends on the source charge. Okay, the force experienced here is independent of the test charge, then depend on the source charge. Okay, that is the third aspect. So, the fourth aspect, what it is saying now, the fourth aspect, you see, we know, I told already, this electric field is a vector quantity. This electric field is a vector quantity. We know already what is vector, what is scalar, we know, we have learned in the last year. Okay, so what is vector quantity? The quantity which has both magnitude and direction. So, the both magnitude and direction this electric field has. So, it is a vector quantity. So, in this vector quantity, you see, the one more thing, if the source charge is here different charges are there. For we can consider this. We can listen. You see, here one point we can take P. Here one Q. Here one R. So between these two, the electric field is E1. Then here this two, E2. This is a vector quantity, so we have to denote this. All are in different distances. All the here one point charge is there, here one charge is there. These are the test charges. Here one test charge, here one, here one. But which is near to the source charge, it is experiencing more electric field and it is exerting more force. This one some distance. So it is the distance increases, the electric field decreases, the force also decreases. So it is experiencing more and more electric field lines from this source charge. So that is the next aspect. Okay. Next point is the test charge. Here this is the source charge. We are using many test charges. First of all, we have used one small charge, one charge, test charge. Here many we have used. But whatever it may be, if we are using the test charges, they may be sufficiently small. If we are using bigger ones, it will move this source charge. So the test charges always they must be smaller than this source charge. That is the next aspect. Okay. So in the manner, one more thing, that formula. This formula is suitable only for the point charges. So for using, if we have more charges, for finding the vector sum, we have to use integral method. If we are using integral method, we can find out. But we can use this method for two charges only. Finite number 2 only for point charges only. If they are bigger size and size of the charge is bigger, we cannot use this. Okay. So in the next aspect is there are different types of electric fields are there. What are the different types of electric fields? There are two kinds of electric fields are there. Uniform electric field, non-uniform electric field. First types. Children, all of you listen. What is uniform electric field? The electric field in the space around a point charge, that is magnitude also same in all the around a charge. The electric field is magnitude also same, like the direction also same. That is uniform electric field. So magnitude same magnitude, next direction also same. Magnitude also same, direction also same. That is uniform electric field. But if we are considering the non-uniform electric field, that is magnitude in the space around this charge. If you are considering a charge around that, at various points, The magnitude also different, the direction also different. So you see here in this case, how can we denote this? Some more longer, like this. So this is show the magnitude different. And then direction also. So in some cases direction also different. Like this, direction also different. So this is now uniform electric field. This is non-uniform electric field. Okay, these are the important aspects. So how many aspects? Ma'am explained here. You know how many? 7 important aspects I have explained here. Okay, all of you understood this types. Then like that, how many important, what is the first aspect? We know the first aspect, the point charge is positive. The point charge is positive, the electric field points away from the source charge. Like that, if the point charge is negative, that is pointing towards the electric field is pointing towards the source charge. Okay, like this one we have to know thoroughly. The next thing, next, electric field due to system of point charges. We can consider a system. That system consists of many point charges. So, for example, we can draw a diagram. This is a system. The system consists of many point charges here. First, we can take this one, P as a point. Here Q1, Q2, Q3, Q4, Q5, Q6. Like this, different charges are there. All the charges together inside a system. So, we can take this point P. What kind of electric field it is exerting upon this point P. Okay. So, this Q1 exerting electric field E1 vector. This Q2 electric field E2 vector. Next, this Q3 E3 vector. Next, Q4 E4 vector. Towards this. Okay, like this. So here, what force it is experiencing? The electric field at an arbitrary, this point we can consider as arbitrary point. Okay, so the electric field due to this, all the other forces towards this arbitrary point is the vector sum of the electric field exerting by this point and exerting by all the other points, all the other point charges. This is the electric field due to the system of point charges. These are the system of point charges, different point charges Q1, Q2, Q3, Q4, Q5. Like this, we cannot take lot of point charges are there. All the charges are exerting an electric field upon this point P. The vector sum of all the point charges due to exerting on it total electric field. Okay, so the collection of point charges are here. So equal to the vector sum of the electric field created by the individual point charges. This is called as superposition principle of this electric field. So already we have learned the superposition principle in Coulomb's law, but here superposition principle in this point charges. Okay, system of point charges. Next, this formula we have to apply here. So E total, E vector total is equal to E1 vector plus E2 vector plus E3 vector, like this it will go. So plus E4 vector. Okay, so E1, E2, E3, E4. So no, here n number of vectors are there. So here we can write En. So in this E total we have to substitute the formula. So E total is equal to, we have to substitute our formula. Already we have in the earlier superposition principle what we have substitute that same thing, but we have to substitute the formula for super. E is equal to, vector is equal to K Q divided by R square R cube. This formula we have to. So K into Q divided by R 1P or 1P vector and Q1 plus Q2 divided by R 2P or 2P vector plus etc. plus Qn divided by R 2n R cap 2n or this figure can take In. Okay, so this is the formula for the superposition principle. Okay, NP. Here NP. FP. Okay, not IP, NP. So this is the formula. How can we write this? According to this integral form, we can write this in integral form. That one, E total vector form is equal to 1 by 4 pi epsilon 0. What is K? K is the proportionality constant. The proportionality constant is equal to 1 by 4 pi epsilon 0. So sigma. So n is equal to, that we can write n is equal to I equal to 1 to n. 1 to n, then Qi divided by R IP or IP cap. So this is the formula. So what is the formula for the E total? 1 by 4 pi epsilon 0 sigma I equal to 1 to n Qi RIP cap. Otherwise we can say like this: 1 by 4 pi epsilon 0 Qi sigma Qi RIP cap, where n I is equal to 1 to n. I we can take as 1 to n. Okay, this is superposition principle of electric field. Okay, now in the next. Children, now up to now we have learned this superposition principle. So superposition principle, the electrostatic force we have learned like this. Superposition principle in electric field also we have learned. Here electric field due to continuous charge distribution. Continuous charge distribution. Before learning this, what we have to see that already what and all questions we have learned today. Okay, that in the last class also, that one we have to thorough like that today. Today important questions, superposition principle, that is important, definition formula like that. Next, electric field, what is electric field and what are the important aspects of electric field, that is important, that is a 5-mark question. Next we have learned the electric field, in this electric field superposition principle of electric field also. So that also important. Okay, so we have to know the formula, that formulas are important, we have to know the formulas thoroughly. Okay, so electric field, next is electric field due to continuous charge distribution. Electric field due to continuous charge distribution. Here in this, we know if you are keeping a point charge or source charge there, it is creating some electric field surrounding it. If you are keeping any other charges nearby, they are experiencing some electric field. So here we have a system of charge. Then we are considering nearby a point P. Okay, because of this the charge, that continuous charge distribution, what is the charge this point P is experiencing? Okay, how much charge this point P is experiencing? So that point P is how we can find out. We want to find out this whole charge, but you see here, whole charge we have to calculate. For calculating, we can divide this into small charges. We can divide this charge into small charges. So dq1, dq2, like that. Okay, so then we can not dq, del q. Del q1, del q2, del q3, del q4, del q5, del q6. Like this different, we want to divide this system of charge into small charges. Because of this, every charge, what kind of charge it is experiencing. This point P is experiencing. Okay, so that only we have to learn now. We have divided. Now the first charge is at a distance R1 from the point P. It is exerting electric field E1. Next, second E2, electric field E2. Third one, electric field E3. Distance also R1, R2, R3, like this it will change. Okay, so the formula we know the formula for this, we can write E is equal to 1 by 4 pi epsilon 0 for the first charge. What do you write? Del q1 divided by r1 square r1 cap r1 p. Okay, so these charges. So next, for all the charges we have to find out. What will you do? E, electric field, this is a vector quantity 1 by 4 pi epsilon 0 This integrate del Q divided by or IP square or IP vector. So in this manner we can find out the whole charge. Okay. So like this we want to find out here Q1, the next Q2 case we want to substitute del Q2. Then R2P. Like this we want to find out. Okay. So that electric field like this it will change all together we can find out by this integral form. Okay. If that charge is distributed in a line or the charge is distributed in a rod or the charge is distributed in a surface. This is the line, the charge is distributed positive or negative, that are no problem, positive or negative discharge. Then sometimes the charge is distributed in a sheet, in a surface, or the charge is distributed in a volume. The charge is distributed. In this cases also we can find out this charges. Okay, we can find out the electric field. The charge is distributed uniformly in this conductor. Okay, the charge Q distributed in this length. So lambda is the linear charge density. Charge per unit length. So that we can take as Q divided by L. Okay, Q divided by this is linear charge density. So that formula we can take the SI unit is the SI unit for this is C coulomb m power minus 1. Okay, this is the formula for this linear charge density. So the formula we can write as E is equal to, we know 1 by 1 that K dq divided by R square R cap. In this dq, what we have to write here? This one we have to say dq is equal to this q is dq, this one dl. So dq is equal to lambda dl. So that we have to substitute here lambda dl. Okay. So this is the formula for electric field in the linear charge density. Like that, volume surface charge density. Surface charge density is sigma. Sigma is equal to Q divided by A. This is linear charge density. What is surface charge density? Charge per surface area. Okay. So here we can write dq is equal to sigma dA. So that we have to write here E is equal to K lambda d here lambda not sigma dA divided by R square R cap. Like that, the next case volume. In the volume, what do you write? This is rho. Rho is equal to Q divided by volume. Okay. So that charge per unit volume. This one charge per unit length, linear charge density, surface charge density, charge per unit area, then volume charge density, charge per unit volume. Okay. So charge per unit volume same time dq is equal to rho into dv. This only. So this one whole manner, but here discrete manner, small. Like that here also. L is capital L. We are taking a small l, small part. That's why we have written dl. This capital Q also bigger for one system, but we are taking a small element. So dq. So here we can write E vector is equal to E vector is equal to K rho dv by R square R cap. Okay. In this way we can find out the electric field for the linear element, for a sheet, the element that charge is distributed over a surface. If the charge is distributed in a volume, this third formula. So in these ways we can find out. This is the electric field due to continuous charge distribution. This is an important question. So you have to know this well. This is the important question, 5-mark question. Okay, so you have to know this. So electric field due to continuous charge distribution. First, because of a system at a point P, what is the charge this point P is experiencing? The vector sum of the small element charges distributed over that surface or that system. For example, system. So here, now linear charge density, it is in a line lengthwise element. This one, a surface at a sheet or a sheet. The charge is distributed. In this case, how can we find out the electric field? Total electric field. Here, in this case, here we can find out. Okay. So, this is for a small element. For whole element finding time, we can use this integral. So, integral finding time, you see, here the integral will come here. Sigma, here integral. Okay. So, here in the first case, here the integral will come here. Here the rho integral. Okay. So, for one small element without line segment, without integral, but for whole all the elements, this line element, length element, we have divided into small dl like that. Here also small dA, all the elements are divided. Here dV, all together we have to find out the integral form. Okay. So children, this you understood, I think. All of you learned well this. This is an important question. What is the linear charge density? Small 1 words also here, small 2 marks also here. So here they can ask this A, B, C. I written like this. This one they can we can expect the questions in separate also. What is linear charge density? Then what is surface charge density? What is volume charge density? Everything we can find out. Okay. Charge per unit length, charge per unit area, charge per unit, charge volume. Okay. So everything you have to know well. Like this today whatever we have learned, I told already. But so everything you have to learn well. If you have doubt, you can ask to me. Okay. So this definitions also important. Superposition principle definitions. Then electric field. If an electric field, then this is important. You have to learn well. So write and see in notes and study well. Okay. So once more I am explaining this superposition principle. What is superposition principle? The total charge, the total force acting on a given charge is equal to the vector sum of the forces exerted on it by all the other charges. That is superposition principle. Okay. That formula also you have to know. Already I written on the blackboard. That formulas you have to know well. Then like that, electric field. That what is the electric field? What this is a vector quantity electric field. The force experienced by charge Q0. Okay. That because then that we experienced upon that is a vector quantity. The SI unit of this electric field is NC power -1. Okay. Newton Coulomb power -1. Then important aspects. All the important aspects we have to know. So learn well. Okay. Thank you.